G'day, this is Mr. Thompson. I'm going to show you how to memorize or how to work out electron configurations using the periodic table. So what do I mean by electron configurations? Well, for example, magnesium is 1s2, 2s2, 2p6, 3s2. All right, but how do we know that? How can we memorize or how can we work out that sequence with just a periodic table? All right, let's start with a little bit of background. When you first learned chemistry, you probably learned that that atoms have shells, electron shells, and so we learned probably that the first shell can have 2 electrons in it, the second shell can have 8 electrons in it, the third shell can have 18, the fourth shell can have 32, 50, etc. You probably learnt those, and you probably learnt that the shells fill up from the inside out, which is, well, it's sort of true. Let's have a look and see what happens. So hydrogen has 1 electron and it's in the first shell. Helium then has another electron and it's also in the first shell. But now that first shell is full. We can't put any more in. So when we come down to the next row, we have lithium. There's the electron configuration for lithium. Beryllium. That's another one. What do we got? Boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay, so we've got our second shell is full, so we have to start filling up our third shell. So far our theory works. Sodium, magnesium, what have we got here? Aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Okay, are we full? Well, no, we're not really full, are we? We've got 8 electrons in the 1, 2, 3 in the third shell, so we're not full, but when we come down to calcium, we find that calcium puts an electron in the fourth shell, which doesn't really fit the model that we were originally taught. So that model that we originally learned, that sort of works for the first 3 shells, but then when you get to the fourth shell, it sort of breaks down a bit, doesn't it? So that was potassium, calcium's like that. Then we get to scandium, and some weird stuff starts to happen. We start to backfill that third shell. Titanium, we backfill the third shell, and it sort of gets a little bit weird. So it turns out if we want to really understand what's going on, we need perhaps a little more complex model. We need to go into a bit more detail. So it turns out that each of our shells actually has subshells, an S subshell, P subshell, D subshell, an F subshell, or these are the subshells that can exist in different shells. And each of these subshells can hold a different number of electrons. So you might have seen it represented with a diagram that looks a little bit like this. So what does this tell us? This tells us in the first shell, that number there is means the first shell, there's an S subshell, and there are 2 electrons in the S subshell. In the second shell here then, we have 2 electrons in an S subshell, and we have 6 electrons in a P subshell. Similarly, the third row here, the third shell, we have 2 electrons in an S subshell, 6 electrons in a P subshell, 10 electrons in a D subshell. If we go to the fourth shell, 2 electrons in an S subshell, 6 electrons in a P subshell, 10 electrons in a D subshell, and 14 electrons in the F subshell. Now it turns out we don't need any more subshells than the F subshell, and in fact we start to run out of elements, so we don't even fill up these outer shells any more than those 2. So look, our first model that we had, where we said we filled up the shells from the inside out, would presume that we sort of filled up going down the rows like this. In actual fact, what happens is the shells fill up from the lowest energy shells, or the energy orbitals, to the highest energy orbitals. And so we don't actually go down the page. What actually happens is we fill them up like this. If we draw diagonal lines, you might have seen, if we draw diagonal lines through this diagram, well, that wasn't very good. You get the idea though. So we're drawing diagonal lines, and that tells us the sequence that these shells and subshells fill up in, from lowest energy up here, from lowest, next lowest, next lowest, next lowest, next lowest, next lowest, all the way to here to the highest subshell. So what we end up with is a sequence that looks like this. And this is the sequence that I started talking about earlier on in the video. So that looks pretty complex. Now, some people will use this model here. So imagine you're in an exam and you want to work out electron configuration. You could draw this diagram up, and you could draw your diagonal lines. That's a bit complex, takes a bit of time, and it's unnecessary. If you've got a periodic table and you can remember just a few small things, I'll show you how we can remember, or how we can deduce this sequence from the periodic table. So all we really have to remember is the order of the subshells. So let's look at the subshells here. So S, P, D, and F. So they're the names of our subshells. So you can see S, P, D, and F. Now, turns out that the S subshell first appears in the first shell up here. So it first appears in the first shell. The second subshell, it makes its first appearance there in the second shell. The D subshell, first time we see the D subshell is when we're in the third shell. And the F subshell, the first time we see the F subshell is here in the fourth subshell. So you can remember S, P, D, F. I don't know, maybe you can make up a silly mnemonic or something. I don't know. Some pigs don't fly. I don't know. I just made that up. But you can probably think of a better one. If you can remember S, P, D, F, I'll show you how to put that onto a periodic table so that you can then work out the magic sequence. Okay, so here's our periodic table. In fact, I've just got a blank periodic table so that you can see what I've written and it's not so confusing. Of course, you'll use one that's actually got useful information on it. But okay, so SPDF. Now, this block over here, so actually you'll notice that helium is usually over here. I've taken helium out and I've moved helium across to here, which is what we normally do. So helium is there. We normally do that when we're talking about electron configuration. And the reason we do that is because you recall that all these elements here in group 1, in the first group, have 1 electron in their outer shell. These ones have 2 in their outer shell, 3 in their outer shell, 4 in it. So we're going to put helium over here because it's more logical for the method that we're using. All right, so now these letters, S, P, D, and F. So we divide the periodic table into these blocks, and this block over here is sometimes called the S block. The S block. Now we said that in fact, let's label the other ones. This one over here, so as we come down the periodic table, that's the first one we hit, the S block. So that's called the S block. The second one we hit is this one over here, called so we call that block the P block. Then we come down even further, we hit the D block, the transition metals, and then down here, the lanthanides and actinides. Actually, you remember that they actually fit in there, so we really should open that table wider and put these in here, but nevertheless we hit them last, and they're called the F block. So far we've just got SPDF, SPDF for each block as we walk down the table. All right, now the other useful fact that we talked about here is the S block. The first shell that the S block appears in is shell 1. So let's just put 1 there. Okay, in fact, I'm going to put 1, 2, 3, 4, 5, 6, 7, like that. And that represents the 1, 2, 3, 4, 5, 6, 7 there. Okay, in our P block over here, the first time we see the P block is in the second shell. So I'm going to put a 2 there. A 2 there. Now be careful you get that in the right spot. Okay, so 2, and I'm going to go 3, 4, 5, 6, 7. Okay, the D block. When do we first see the D block? We first see the D block in the third shell. So I'm going to put 3. Okay, this is the 4th row. 1, 2, 3, 4. But no, I'm not going to put 4. I'm going to put 3 because the first time we see the D subshell is in the third shell. So I'm going to write 3, 4, 5, 6, and F. Well, we first see F in the 4th shell. So I'm going to put 4 and 5. Okay, so you'll notice here. So remember, all we remembered so far is S, P, D, and F. F starts with a 1. P starts with a 2, D starts with a 3, and F starts with a 4. Easy so far. Okay, so we're nearly there. Now all we've got to do is walk across the table once we've set it up like that. So here's the sequence that, that we should end up with. Let's work out how we get that. So what I'm going to do is I'm going to start over here and I'm going to walk across the table. And as we walk across the table, each time we get to another element, we're going to add another electron. So the first thing we're going to do is we're going to add, we're in shell number 1. Shell number 1, which is we've got a 1 there, and this is our S block. So 1s, okay, so 1s1 and 1s2. So we've got 2 electrons there. Okay, now we go across here. So we're walking across the table there like that. Okay, and we come back to here. All right, so so hydrogen, helium, lithium, beryllium. So okay, so now we're in our second shell because we've got a 2 there. And this is our S block. So 2s and 2s1, 2s2. So we've got 2s2. So far, so good. It's working for us. Okay, now we come across our table again. Okay, boron, carbon, nitrogen, oxygen. As we come across here, okay, this is now our P block. So we're still in our second shell. We know we're in our second shell because we've got a 2 there. Okay, 2. And okay, as we come across here, how many, so it's 2p, but how many electrons can fit into our P shell? Well, it's easy. 1, 2, 3, 4, 5, 6. 6. So 6 electrons can fit into our P subshell. The width of that block on the periodic table tells me that. See, the width of this S block was 2, so we could fit 2 into our S subshell. We can fit 6 into our P subshell because of that width there. All right, so after 2p6, we come back here, we come to the next row. We've got a 3 here. So we've got 3, it's the S block, and 1, 2. We can put 2 electrons in there. Okay, so look, so far so good. We match. All right. Now we come across again. So we're coming across the table again. Okay, now we're across to the P subshell, the P block. So that's 3, P, 1, 2, 3, 4, 5, 6. Okay, so far so good. And so far we're filling up from inside shells to outside shells. Okay, it's going to start to get a bit interesting now. So we've come across, we've come all the way across here. Okay, now it's time to hit. Now we hit 4s. So 4s2. So 4 because we've got the number 4. 1, 2. Now we hit this transition block. Now we hit the D block. Now we've got a 3 there. So we're actually not going to fill the fourth shell. This is the backfilling. So we have 3 because we put a 3 there. And 3D. So 3D. And how many electrons can we fit into the D subshell? Well, again, we can look at the width of our table. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3D, 10. Okay, as we come across here, 3D, 10. Now we're in the P subshell, and we're 4P. So 4P, and we add 1, 2, 3, 4, 5, 6. 6 there. Okay, so that's that row done. Now we can come across to this row here. Let's do that. Do that quickly. Okay, so we've got 5s2, 4, because we've got a 4 there. So that's a 5 there, but that's a 4 there. So 4D, again, we've got a width of 10 across that block. And then we come over here to 5P, and we've got, again, a width of 6, 5P6. Okay, it's going to get a little bit more interesting now. So now we come down to, we're down to this row here, this period here. So we've got 6s2, that takes us to there. Okay, now as we come across here, we've got, now we're not going into the D block. Remember now, this is where we have to remember that the lanthanides and actinides actually belong in here. Okay, so they actually belong in here. So after 6s2, we're actually going to go, this is our F block. So 4F, how many have we got there? We've got 14. 4F14 as we come across the F block. Now we go across our D block. Okay, and we have 5D, what have we got? 10, 5D10, and then 6 7p6. You can see what's happening here. Okay, 7s2, and again we've got to go down here through the F block there. So now we're up to 5, because there's a number 5 there. 5f, that's 14 wide, so 14. And then we come back up here and continue along the bottom row of our periodic table. So that's 6d, so 6d 10 wide, and 7p6. So we've completed walking across the periodic table, and here's our sequence, and I think we find we got that pretty much right. That looks pretty good. Okay, so that sequence there I've deduced only by knowing S, P, D, and F, and knowing how to annotate that periodic table, and then walking across the table, we've worked out our sequence. Okay, I said we were nearly finished before. This time we really are nearly finished. Okay, let's do an example. So here we go. I've got my periodic table, and as I mentioned before, you'll have a real one which has got all your elements on it. I've got a one without elements, just so it's a bit clearer, so you can see what's going on. Okay, what if we do the electron configuration for, I don't know, let's pick aluminium. Aluminium. So the electron configuration for aluminium. So what we're going to do is we're going to find aluminium on the periodic table. Aluminium on the periodic table is here, Al. Okay, and we've annotated our periodic table. So what I've done, remember all we remembered before, we remembered S, P, D, and F. Okay, we've marked out our S block, our P block, our D block, and our F block, and I've numbered. S block starts with 1, P block starts with 2, D block starts with 3, and F block starts with 4. So that's not too hard to remember. All right, so now we're going to walk the periodic table, and we're going to walk across the periods, adding electrons until we get to aluminium, and that'll tell us what our electron configuration for aluminium is. Okay, so we're going to start up here. We always start here, so we're going to go 1s1, sorry, no, 1s2. 1s2, so one electron there, another electron there. We come across the top of the periodic table here, and there's no more elements over here, so we get to the next period. So now we're in the second shell, 2s2. Okay, then we've got 2p6. Okay, then we've got our third shell. We're going 3, or in the third period anyway, 3, not 3p, 3s2, and now we come across here 3p, well, it's not 3p6 because we're not going to add all these electrons. We're going to stop once we get to aluminium. So we just add 1 electron for aluminium, 3p1. So if we add up, 2 plus 2 is 4, plus 6 is 10, 12, 13. We've got 13 electrons, and the atomic number for aluminium is 13, so it should have 13 electrons. So we got that right. All right, let's do another one. Actually, let's show you how to do aluminium if I was going to use the abbreviated electron configuration, in which case we're only interested in the valence electrons. In other words, we're only interested in the outside electrons. I can do this. This is sort of cheating. So aluminium, what I'm going to do is I'm going to find, okay, here are our noble gases down here. Let's label them: neon, argon, krypton, xenon, radon, and my goodness, I don't know how to pronounce that one. Ogneson. Anyway, there it is. So there are noble gases. So you will recall, I hope, from class that when we write the abbreviated electron configuration, all we do is we find the noble gas from the period above the element that we're interested in. So we've got aluminium. The noble gas in the period above aluminium is neon. So we're just going to start with neon. So we're going to put neon in square brackets, Ne, like that. And what that means is we're going to take the electron configuration for neon, which is, what is it? That there. And then on top of that, let's just walk the periodic table again. So we're starting from neon. So if we start from neon, we come to 3s2 and 3p1. 1. Okay, so there's the full electron configuration of aluminium, where we started from hydrogen and went all the way down the table. And you can imagine if we were trying to do something down the bottom of the table here, like, I don't know, tungsten or something, that might be quite a long electron configuration. And the abbreviated configuration, where we start with the noble gas that was just before the element that we're after, and we walk the periodic table. And this tells us that we've got the core electron configuration of neon, and the interesting electrons, the valence electrons, we've actually spelled them out in full. I hope that helps.